Okay, hello grade 10s. So yesterday we did completing the square. Today we're going to do the quadratic formula. Super handy thing the quadratic formula is. What I would like you to do first though is this first 5-minute question. I've given you a standard form and I want you to find the vertex, but I want you to do it without factoring. Okay, so give that a shot. Okay, here we go. What is the vertex? Well, to find the vertex we complete the square. So step 1, we take -2 out of the first two terms by dividing both terms by -2. Now, we have x squared minus 3x in brackets. We take -3, we divide it by 2, we get -1.5, and then we square -1.5, or just 1.5, it'll be the same result. You can basically ignore the negative at this point. And we get 2.25. So this means that we add 2.25 and then we subtract 2.25. We get -8. Remember, adding and subtracting the same number ensures that nothing has changed. Now we factor this first three terms here. So we need two numbers that multiply to 2.25 and add to -3. Well, we know that 1.5 times 1.5 is 2.25, and if we make them both negative, we'll have x minus 1.5 and x minus 1.5, or x minus 1.5 squared. Now the tricky part is that you also have to multiply -2 by -2.25 to get it out of the brackets. I believe that will be plus 4.5, and then at the end we still have -8. We collect our like terms at the end, and we get 4.5 minus 8, which I believe is -3.5. And now let's check it in Desmos. Okay, so I factored the original equation, and I got 1.5 and -3.5. For the vertex, I actually never said what the vertex is, so that was the question. So vertex is, we change the sign here because that's what we learned quite a long time ago, and the sign on the k value stays the same for the y value of the vertex. So that works, right? That's the vertex. We did it correctly. You'll notice there are no zeros for this. So if we tried to factor this, we would not be able to factor it. Okay, so let's move on to today's stuff, and that is the quadratic formula. But first, I just want to do a quick what are my zeros, just to make sure we're all clear. Okay, so if I said what are my zeros here, I would love for you to pause it and try it. It should only take a second. They are -4 and 3. What are my zeros? Please pause it and try it. There are none. The zeros happen along the x-axis, and the curve never gets there, so none. What are my zeros? Please pause it and give it a shot. Around -3.6, and this one is around 0.9. Okay, so if we factor, we're probably not going to get results like this, especially if these numbers are ugly decimals that never terminate. If they're not nice fractions, sometimes you just can't factor, and that's what today is for. So let me tell you about the quadratic formula before I have you watch the video. The quadratic formula is awesome because if a quadratic has zeros and can't be factored, or can't be easily factored, it lets you find them, even if they're hideous, ugly decimals. There's a song, a really catchy song that helps you remember it. All right, here's the link for the song. I encourage you to watch it. I won't sing it for you. I don't want that recorded and posted on the internet. But it is the quadratic formula song. It's to the tune of Pop Goes the Weasel. And if you ask Preston from last year, or maybe the year before, I think it's been a couple of years, he still knows it, and he will sing it for you. I promise you that. Okay? So it's got a song. It's a great song. And let me go through a few more things, and then we'll actually do it. It'll be a quick lesson today because it's just using the formula. Students sometimes mess up the quadratic formula because they don't memorize it. You need to memorize this. I don't know that we'll have an exam this year. It looks like we probably won't because they announced yesterday that schools don't go back. But next year it'll be assumed that you know it, so know it. They don't have their own calculator, and they're doing it like on Desmos right now because they're at home or they're just typing it into Google, and that's great now when you're in grade 10 and your marks don't matter. But next year, when you probably won't have the option of doing stuff on your computer or looking up stuff online, you do need to know it, and you need to have used your own calculator. So please use your own calculator to make sure you know how to. And number 3, they don't practice punching into the calculator because they think it's so easy. And then when it comes time to do it for real, they have no idea how to do it. And the 4th option is this. They forget about there being 2 possible answers. Okay, so because we're looking for the zeros of a quadratic, there can be 2. Now let's look at the formula. So here it is. It's right here. I'm going to highlight it. X is equal to negative b plus or minus the square root of b squared over 4ac, b squared minus 4ac, all over 2a. So it's important that you notice this division sign goes the whole way. So everything up top gets divided. Now the other thing you should notice is this plus minus sign here. Okay, that plus minus sign is very key because you might remember last unit when we would rearrange a vertex form, we'd have a plus or minus when you took a square root. That's because like the square root of 4 is 2 or negative 2. And this plus or minus is what gives us 2 possible answers. So let's do it. First, we're going to factor it. Okay, so we've got 2x squared plus 5x minus 3, and we're going to factor. All right. So I can't common factor. It's a complex. So I need 2 numbers that multiply to negative 6 and add to positive 5. And that is going to be minus 6 plus 1. So 2x squared minus 6x, plus 6x minus 1x minus 3 equals 0. I might have said the numbers wrong, but just remember these 2 numbers have to add up to positive 5x. And now we factor out 2x. We get x plus 3 minus 1. X plus 3 is 0. We get x plus 3 times 2x minus 1 equals 0. And therefore, x equals negative 3 and 1/2. And if you don't know where the 1/2 came from here, we set this equal to 0 and solve, and we rearrange for x and get 1 over 2. Okay, so this is or 0.5, same thing. All right, so that wasn't too hard, right? Like if you know how to factor and you're good at it, if you have one of these, you should probably factor. But we can also do it with the quadratic formula. So here it is up here. And remember, this is A, B, and C. So A equals 2, B equals 5, and C equals negative 3. So to solve for the zeros, x equals negative b, so negative 5. And people always ask the question right now, if b was already negative, would this change to a positive? Yeah, absolutely. It would be negative 5, which is positive 5. So plus or minus the square root of b, which is 5, squared minus 4ac, all over 2 times a. And now I just simplify it. So x equals negative 5 plus or minus. Now with a calculator you could do this faster, but 5 squared is 25. And then minus 4 times 2 times negative 3. 4 times 2 is 8. 8 times 3 is 24. We've got a double negative, so this is going to be plus 24 all over 4. So under the square root sign, we get x equals negative 5 plus or minus the root of 7 all over, sorry, I jumped the gun there. It's the root of 49, which is 7, but we'll do that next. Okay, so then it's x equals negative 5 plus or minus 7 over 4. Now we're not done. We now have 2 cases. So we have x equals negative 5 plus 7 over 4, or x equals negative 5 minus 7 over 4. Negative 5 plus 7 is 2. 2 divided by 4 is 0.5. Negative 5 subtract 7 is negative 12. Divided by 4 is negative 3. So you can see we have the same answers. And you're probably thinking, why would I ever use this? It's so much longer, it's so much harder. Well, all I'm trying to prove to you here, or sort of suggest to you here, is that when factoring is possible, this is the quick way. This way always works, even if it can't be factored. Okay, so the quadratic formula is necessary when something doesn't factor. And I would say the majority of parabolas probably don't factor, because the odds are if you have a bunch of random numbers for a, b, and c, it's not going to factor. And certainly real-life quadratics, especially if we're talking about projectiles, like the speed of something or the height of something over time, those aren't going to factor because real-world numbers are ugly. Okay, so that's the quadratic formula, take one. We're going to do it 4 more times, and then we're going to do a word problem. Okay, so please pause it and try it now. It would be very beneficial for you to try it at least once, or each time here as we go. So hopefully you've paused it and tried the first one. Now here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so negative 4 plus or minus, and then here this is going to be 16, and then 4 times 2 is 8, times 10 is 80, so this is going to be 16 plus 80, which is the root of 96, I guess, all over 4. Let me check that on the calculator. So we've got 16 minus 4 times 2 times 10 negative equals 96. Okay, so now we've got to take the square root of 96. So last time it was easy, it was 49. I think this one might be a little bit uglier. Where's my square root button here? Anybody see it? Ugh. All right, let's say approximately 9.80. So x equals approximately negative 4 plus or minus 9.80 over 4. And then we've got x equals negative 4 plus 9.80. Remember, it's approximate, so I put a dot over the equal sign, divided by 4. And x equals approximately negative 4 minus 9.80 over 4. I didn't leave a lot of room here for me. Let's go back to the calculator. So we've got negative 4 plus 9.80 divided by 4. So we've got approximately 1.45. And then we've got negative 4 minus 9.8. Negative 4 minus 9.80 equals, divided by 4, and negative 3.45. Let's go to Desmos and see if that worked. Okay, so 2x squared plus 4x minus 10. 2x squared plus 4x minus 10. And we've got negative 3.449. We said negative 3.45 and 1.449 or 1.45. I would say we did it. Now, try and factor that, see what happens. I don't think you're going to have a lot of luck. You can common factor out the 2, and then it's x squared plus 2x minus 5. It cannot be factored unless you are insanely good at figuring out factors with like 3 decimal places, which, if you are, that's awesome. I could not do that. All right, part B. Again, please pause it and try it. Here we go. X equals negative b. Well, b is negative 4, so this is going to be positive 4, or negative 4, plus or minus the square root of b squared. Now, it doesn't matter that b is negative under the root sign because you square it anyway. Minus 4ac all over 2a. So x equals 4 plus or minus. So this is going to be 16 plus 60, I think. So we've got 16, and then the negatives, everything multiplies here. So a negative times a positive times a negative is a positive. So 20 times 3 is 60, so plus 60 is 76. And we take the root of 76, 8.72. Approximately 8.72 over 10. So x equals approximately 4 plus 8.72 over 10. Or 4 minus 8.72 over 10. So 4 plus 8.72, whoa, 4 plus 8.72 divided by 10 should be 1.27, approximately 1.27, 1.27, and 4 minus 8.72 divided by 10 is negative 0. Negative 0.47. Again, let's go to Desmos and check. So I've got 5x squared minus 4x, so 5x squared minus 4x minus 3. And I've got negative 0.47, yes, and 1.272, yes. Okay, so I rounded to 2 decimal places. You can keep 3 if you want. I'm not going to be a stickler on that, but definitely keep 2 if there are 2. Now, if I asked you to find the axis of symmetry of this, how would you do it without Desmos? Correct. You would add up the zeros and divide by 2. So 1.27 minus 0.47 divided by 2. So the axis of symmetry should be 0.4, and it is. And then you would plug in 0.4 into the equation here to get the y value, and that would be it. Okay, the next one, C and D, I'm going to tell you step 1 is to rearrange them so that they're in standard form. Okay, so let's go. So for this one, first, we subtract 8 from both sides, and we get 2x squared minus 18 equals 0. So this means that a is 2. And what's our value of b? Remember, b is attached to the x. I don't see anything, so b is 0, and c is negative 18. Okay? So if we're going to use the quadratic formula, our b value is going to be 0. And that should actually make things a lot easier. So x is equal to negative b, so 0, plus or minus the square root of b squared, so 0 squared, minus 4a c, all over 2a. So x is equal to 0, plus or minus the root, and this is going to be, looks like 72, the root of 72 over 4. So 18 times 2 is 36. Oh, I think it might actually be 144. I'm going to check that because I did it in my head and didn't do it right the first time. Okay, so it's going to be 4 times 2 times 18. It's 144. Oh, the square root of 144 is 12, so this is going to be x equals 0 plus 12 over 4. Or 0 minus 12 over 4. And in this case, the zeros are going to be 3 or negative 3. I'm not going to check that one because I feel good about it. All right, last example until we do the word problem. All right, so this is nasty. You'll see stuff like this in the textbook all the time. The first thing we got to do is expand and rearrange and simplify and just break everything down as much as we can. So I just distributive propertied those, x squared and then minus 4x plus 12, because the negative 4 got multiplied through, and bring everything over to the left. So I subtract x squared from both sides, I add 4x to both sides, oh, still got that plus 2x there, and then I subtract 12, and now I combine those two like terms. Okay, and there we go. And now we've got the quadratic formula. So x is equal to negative b. You could have just said 6, but I'm just showing you that it doesn't matter. B squared minus 4ac all over 2a. So x is equal to 6 plus or minus the square root. Okay, so now we've got negative, positive, negative, so that'll all cancel out. So we've got 4 times 14 times 12, and then we add the 36, we get 708. 708 all over 28. The square root of 708 is ugly, so 26.61. So x equals approximately 6 plus or minus 26.61 all over 28. So x equals 6 plus 26.61 divided by 28, which is 1.16. Or 6 minus 26.61 divided by 28 is negative 0.74. All right, let's go to Desmos and check this out. Okay, so I'm going to write that whole original equation and see what happens. 3x bracket 5x minus 4 plus 2x equals x squared minus 4x minus 3. Okay, we've got answers. Negative 0.74. Oh, yeah. And 1.165. And it's rounded a bit off, but there were a lot of decimals that I rounded. So this is good enough. The procedure was correct, obviously. Okay. Last one. So this is a word problem. This is the last thing we're going to do. A rectangular field. So right away, draw a rectangle. Is completely enclosed by 100 meters of fencing. So this is the perimeter. It's 100. Okay. Create a quadratic relation that shows how the area will depend on its width. So area is length times width. That's important to remember. Okay, and let's go here. Let's let the width equal x. So width is x. Because it says depends on its width. So we're going to make the width x. That's going to be our variable because as the width changes, the length and the area and the perimeter won't change, but the length and the area will change. Okay, so if this is x and this is x, what's left for this side here? Well, let me talk about it a little bit differently. If we had two sides of this rectangle, one width and one length, if we added them both up, just one width and what length would that be? I would really like you to pause and think about this question. If we added the width and the length, one of each, how long would that be? Hopefully you thought about it. We've got 100 meters total. This is half the rectangle. So these two things together are going to be 50 meters. Okay? So if we go to our diagram here, if this is x, how can we express this? Well, we know that this plus this is 50. So we have 50 available for this length here, but we have to take away the width. So 50 minus x. Okay, that is the hardest part of this question. From here, it's all super easy. Coming up with this is the hard part. So then we've got area equals length times width. I'm going to put the single term out front, just like this. Okay? So there you go. I'm going to expand it. So 50x minus x squared, or the area equals negative x squared plus 50x. Okay. All right. Now, Determine the dimensions of the field that will result in an area of 575. So that's going to look like this. Area is 575 is negative x squared plus 50x. And let's bring everything over to one side. So we've got negative x squared plus 50x minus 575 equals 0. Now, if we're going to solve this, we're going to solve for x, we're going to solve for the width, we need to find the solutions, which in quadratics means factor, or, as of today, use the quadratic formula. Now, you could try to factor that. I'm not going to, because I want to use the quadratic formula because that's what I use today. So x is equal to negative b plus or minus the square root of b squared minus 4ac. Note here that a is negative 1 because we can just put a 1 there. All over 2a. So x is equal to negative 50 plus or minus the square root. Okay, so in brackets here, we've got a negative times a negative times a negative. So this will actually be negative. So 4 times 575 is 2300. So 50 squared minus 2300. So we get 200 under the square root sign. All over negative 2. Okay, so we get x equals, and the square root of 200 is 14.14. So x is approximately negative 50 plus 14.14 over negative 2, or equal to negative 50 minus 14.14 all over negative 2. So let's do each one here. So negative 50 plus 14.14 is negative 35.86 divided by negative 2 is about 17.93. Or 50 negative minus 14.14 divided by negative 2 is 32.07, or equal to approximately 32.07. Let's check this in Desmos. So we had 575 equals negative x squared plus 50x. Okay, and here's our answers. 17.93, yeah, and 32 point, yeah, awesome. Okay, cool. So for the area to be 575, the width is 17.93 or 32.07. So for the area to be 575 meters squared, I assume, we need a width of 17.93 meters or 32.07 meters. Now here's an interesting thing. If we want to find the length, so 50 minus 17.93, if the width is 17.93, the length is 32.07, which makes sense, right? Because those two numbers always have to add to 50, so we sort of got both answers here. Cool. All right. Later in the unit, I'm going to ask you what would be the maximum area here, and then we'll see what you do. Okay, so that's it for this question. It's a hard question for sure. Be sure to look for some of those in the textbooks to try. Again, I think the hard part was this, recognizing the 50 minus x. From there, area is just these two things multiplied together, so I expanded. We were given an area of 575, so I collected everything to one side, and then I just solved, and that's it. Okay. Please get in touch if you have any questions. Here is the homework. I didn't assign anything from 1 to 7, but that's the basic stuff, so feel free to try that first. I'm trying to just assign the stuff that I really, really want you to do, and so that is the questions that I put here, but you should be able to do the ones before this. So if you want to test the water with like 1 to 3 or something like that,
feel free to do that.
Okay, folks, good luck. Email me if you have any questions. You want me to set up a Google Meet and give you a hand or whatever. I'll do one tomorrow, Thursday at 1 p.m. Or sorry, today, Thursday at 1 p.m. I forget that I post these the day before you see them. So today, Thursday the 21st at 1 p.m. Thank you.